Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about a design of synchronous sequential circuits. So these are all the slides we are going to see in this video: introduction, state representation, state minimization, design flow, application, followed by assessment. Introduction. Generally, the sequential circuits are based on number of flip-flops are combining with the combination circuits. The flip-flops are working under the different clock pulses because the clock pulses only decide the flip-flops of the corresponding input signals. So based on the flip-flops, we can able to have the different number of input signals. Challenges in synchronous circuits. The students are a little bit confusing while selecting the number of state because the green color indicate that the students are a little bit confusing between the state selection because they don't know about how to select this Q0 Q1 like this, so that there may be some small confusion between the selection of the state while forwarding the informations. And DT define why synchronous circuits are needed. So the circuit has been used for a lot of applications, especially for industry like Intel, AMD process. They are using CPUs, and for Siemens they are using program logic controller for controlling applications, and for Qualcomm companies they are using system on chip for communication devices. Flip-flop choices in synchronous. So different flip-flops are using for different operations, especially for SR flip-flops are simple, but it is an invalid state issue has been used, and JK flexible toggling property has been analyzed, and the data delay transfer and pipeline processing they are using D flip-flop. For T counters and frequency division process they are using. So like this, all those flip-flops are using clock signals. Based on the clock signals only they can able to send the informations. The clock signals generally two types. First one is positive edge and negative edge. If positive edge means number of pulses is in high position, it is in 1, and for negative edge it is in a down position, it is a 0. State representation. The state has been represented based on the number of input signals, and it can be differed for all those flip-flops, especially for SR, JK and D flip-flops. They are having different state for giving the input signals. For example, if you are giving 0 0 means then automatically the values has been forwarded to the destination side as 1, and the cycling of the reset state also differed for each flip-flops. After finalizing the flip-flop, we need to have a state tables for representing the corresponding terms of the states. Ideate. So each state has been represented based on the minimization. So here lot of states are there. After states we need to configure the number of states are assigned, and next that we can eliminate the simple state and eliminate the state which are to be removed. So the next one is the removed state has been eliminated from this. After that, the same state S0 is also present, the same number also there. So we need to eliminate the same state so that we can get the number of state in a minimized position. Design flow. After state reduction and state minimization, we can go for the design. So the design is nothing but the implementation of the circuit. Once the problem has been identified, then the state diagram has been fixed. Once the state diagram fixed, then we can use the excitation table for flip-flop. Once finalized, then a state table has been produced. After minimization of the state table, then the corresponding Boolean expression has been marked. Then the marker of the Boolean expression will be the formed as a state map. So then it can be implemented towards the implementation process. Applications: finite state machines, memory devices, digital signal processing, data transfer protocols, clock division circuits. These are all the essential factors in digital circuits. These circuits has been used nowadays as a real-time process also. Yeah. summarize, once if you are confirming the states, then we can able to know the concept of the mind map is very useful to know about the concern terms, especially for modes and synchronous asynchronous circuits. It will be very useful to know the particular concept of the devices activity. So here I have given think parser, design a sequence detector for 101 using D flip-flops. Take a 5 minutes to think about it, then discuss with the partner. Consider what is the truth table of D flip-flop, because D flip-flop, if you are knowing the D flip-flop truth table only, we can able to mapping the sequence detector. The hint is state diagram and state table and flip-flop excitation. Assessment. First question, in synchronous sequential circuit, the state transition occur based on input changes only or output changes only, or clock pulses and input values, or D feedback signals only. So the option is C, because based on the clock pulses and input values only the state transition occurs. And second question, which hardware component primarily stores the state in synchronous sequential circuits? First one is multiplexer, flip-flop, encoder and decoder. The option is flip-flop. The flip-flop is a storage device. It is a 1-bit storage device, so that it can be used for sequential circuits. So these are all the websites I have referred for this PPT. Thank you.